Hello and welcome to my lecture review for the textbook, Internet and Web Application Security, 3rd edition. This is done by Jones and Bartlett Learning. Again, copyright, they own everything. This is their book. I'm using their PowerPoints. I'm just providing video lectures for my courses that are using their official book. The assumption is you own the book and you are in one of my assigned courses. The book ISBN number 9781284206166. Again, copyright for the Internet and Web Application Security 3rd edition by Jones and Bartlett Learning is owned and maintained by them. These are just video lectures on their official PowerPoints, so let's jump on in. Welcome, Chapter 5, Mitigating Website Risks, Threats, and Vulnerabilities. So, in this lecture, we're looking at identifying and mitigating web-related risks, threats, and vulnerabilities, looking at the types of traffic to websites, looking at web analytics that drive quality and qualified traffic to a website, again, looking at legitimate traffic, how to accept user input on a website, looking at OWASP and understanding the top 10 threats and other web threats that are out there. Lastly, looking at strategies and best practices for mitigating known risks, known threats, and known vulnerabilities. So, let's go ahead and jump right on into the lecture. Who is coming to your website? That's a huge part of understanding data analytics for improving your web content. If you do not know who is using your web resources, then it kind of makes it harder to understand what's going on. So, for example, an e-commerce website needs to have a clear understanding of the traffic visiting their site for both security and for marketing purposes. Are they coming to look at a specific product? Are they coming to look at a specific range of products? Are they actually purchasing a specific product? All of that kind of more focuses on the marketing prospect of things, but without that data, you don't know to increase maybe advertising on that specific item or keep more inventory or things like that. So all of that is more looking at the analytics. So some of the more common analytics done for web trafficking is things like location. Where is the visitor's location currently? What's the visitor's source? Visitor type. How they navigated there. Average time on the site. And how often do they stay on the site, or when do they leave? Even YouTube, same thing. When we're looking at data analytics, where is my audience member located? How long are they staying on a video? How long are they staying before they leave? Are they clicking through? All of those things are brought up so that I can make better content. Marketing purposes for e-commerce sites are the exact same thing. We use data to make better decision making. The nice thing is Google Analytics is a more common web analytics software package, and it's fairly easy to use. It is not the only one. There are tools out there that I think provide a little bit better look and feel, but Google Analytics is definitely out there, and it's one of the tools. It does provide you a nice dashboard to understand the visits, the site usage, visitor overview, map overlay, and content overview. Something that looks like this gives us details so we can make better decision making. Map overlay would be an actual map, and that way you can kind of see where your target audience is. That way, if you know that you're getting more traction in a specific country, you might tailor content to that area. So, whom do you want to come to your website? When I'm doing web design, I'm looking at, well, who is my customer? Who am I going to be driving this content for? So driving quality and qualified traffic is a serious strategic process. Characteristics of a site demographic basically forces you to determine that demographic and their role in that site design. You need to be able to do customer profiles based on your desired demographics. If women are your target demographic and you're using color schemes that aren't pleasing to them, they may spend less time on your on your website. So that might then lower traffic. So all of this plays into kind of getting customers to your site and keeping them there. A profile is a description of your customer base on various criterias: age, sex, gender, marital status, location, occupation, education level, and so forth. Identifying the demographics for a website allow you to tailor to your visitor. It creates a design suited for that specific group. It pinpoints characteristics of your ideal customer, and it allows you to identify the geographical areas with the highest number of ideal customers, thus allowing you to target them a little better. Subaru did that in the 90s. They kind of weren't selling cars very well. They started collecting information and data, analyzing it, and then they found a specific niche market that they could then tailor ads to, and that drastically increased the sales of that product. I didn't want to be too specific because the algorithms kind of don't like certain words, so I'm not using certain words. But Subaru, early 90s marketing, you can figure it out from there. Alright, moving past that is accepting input from your website. Does your website have a search? Can it actually take input from a user and then return results? Sometimes this can be exploited. Uber had a flaw in their website that returned too much information when you searched for users. Turns out it would deliver like social security numbers and phone numbers and addresses. It has now been fixed, but websites need to test user input to make sure they don't return too much information. So websites have an interactive element designed to engage visitors so they can come back to the site. Also helps allowing them to find the details that they need. So the interactive element may be introduced, again, security considerations, phishing, bullying, stalking, exploitive PII, and things like that. So corporate sites provide various forms of inputs: forms, surveys, feedback forms, emails, other contact information that might be more publicly available that could be used in phishing campaigns. So the input mechanisms are designed to increase interactivity and communication to the visitors, but they can also increase security concerns. So, things like forums. You can actually have a increased repeat visitors if your forums are active and relevant. It does increase keyword exposure to your search engines. Email address acquisitions, assuming that you're allowing your forum users to sign up for an account with an email address, and it then allows them better data analytics to gather more details. It does help support an online relationship between the website and visitors. The disadvantage of these are technical expertise, content monitoring, policing, common things like bullying and stalking, and you definitely run the risk of flooding content that may not be appropriate, like ads. But forums aren't the only way that this can be done. So they could be a feedback form, like a contact us form. It could be an input form that is directly submitted through the website, sign up forms, things like that. Or it could even be like an online survey. These are all things that are great, are there for users to have, but these are also great things for attackers to exploit. So, like an online survey provides a great way for visitors to communicate, gather information, provide methods to interact with the site, be brief but be useful, and again, great add-ons to a site. But there are security concerns. A lot of the online security concerns come back to the Open Web Application Security Project known as OWASP. every year, or every so many years, OWASP does a top 10. And they may change, and these are common threats for web apps. And these are high-level categories, and then there's subsections for each one of these. The top 10 right now are broken access controls, cryptography failures, injections, insecure design, security misconfigurations, vulnerable and outdated components, identification and authentication failures, software and data integrity failures, security logging and monitoring failures, and server-side request forgeries. So we're going to dive deep into each one of these. Alright, so let's jump into describing each one of these. So broken access control. Vulnerabilities created through the assumption that access controls are automatic features of a router, firewall, misconfiguration of the settings, rules, controls, implementations. Basically, you assume that access controls are there and you don't actually check them. The best way to mitigate is through the principles of least privilege, and again, tests, verify. Do not assume that things are functional. Next to the cryptography failures, this is known as sensitive data exposure. It removes all or portions of the encryption protection that was used to protect sensitive data. I.e., maybe you have a social security number, a name, an address, and it was stored securely, but somehow you managed to store it insecurely on the web server, exposing it. Well, that's cryptography failure. Mitigation, inventory and classified data at rest and in transit, encrypt sensitive data at the rest, use secure protocols, use authentication encryptions, use RPBKDF, ensure cryptography randomness is based on appropriate measures, avoid depreciation cryptography functions. Again, test, check, verify. Don't assume that everything is hunky-dory, but actually work within the system to ensure a layer of protection. You're going to notice the most common theme for a lot of this is check, verify, test. And oftentimes I get told, oh, well, that's so common. It should just be done. Yeah, it should just be done. Yet, some of the more basic things that you'd assume were done are things that are being exploited, even with large businesses. So, don't assume that things are correctly done. So, here is an example of a Windows machine looking at NTFS and looking at the security features on a specific folder. This is looking at eDrive, documents, 2022, JBL edits for the Internet and Web Application book, and this is looking at this person's desktop. Desktop name 5i0RQST, and the different groups that are associated with it. Moving on, other forms of attacks are things like injection, and an injection flaws allow attackers to relay malicious code through the web app to another system. More common is an SQL injection. You can actually feed code in a search engine or even a login box, and if you feed it SQL code, it might actually execute it as if it was SQL code. So you can sanitize the inputs so that only certain inputs are allowed there. You ever go to a box and it says enter email address, and if you don't enter something at something.com or something dot, let's try that over again, something at something dot something, that type of structure, it may say invalid email address. That's an example of injection prevention because it's looking at the formatting. So least privileges is a big one here. Data sanitation, input validation is also important here. After that, insecure design. This omits or misapplies security measures. This is a common thing that I've seen. A lot of security people don't understand web design. A lot of web people don't understand security. So these two teams don't actually work together to provide a base level security measure for an appliance or a server that will be sitting on the network. I.e., misappropriate or misapplied security measures because the two teams aren't working together. Mitigation, understand the threats, risks, and exposures, as well as the vulnerabilities that might be targeting your industry, and ensure that your organization's web apps are being protected. That means these two teams have to work together. Security misconfiguration, basically failures for a system admin or security personnel to understand the default configuration settings of the hardware, software, and the configuration changes needed to fit them into the existing infrastructure. i.e., sometimes people design the controls incorrectly or don't test the controls, so it opens up new vulnerabilities. Mitigation, test, check, verify. Security audits, review SDLC, understand the functions and roles of the system. Train, research, test, verify. Do vulnerability assessments, do a vulnerability scanning. If it's a custom web app, have a third party check, verify. That way you can make sure things are running correctly. After that, we have vulnerability and outdated components, lack of inventory, software outdated, unmanaged, no vulnerability scanning, patching not actually being applied, and a lack of testing and verification. A lot of the last major threats have been because things were outdated, never scanned, and patches have been, 6 months behind. Mitigation technique is using system hardening techniques, keep inventory current, track installed software, and patch appropriately. Also, make sure to do your vulnerability scanning, and make sure that you do spot checking for patching. Ensure that you have some type of inventory management that checks patches. That way, if you're too far out of date, you get warnings or alerts. Here's an example of dependency walker application, and you can see the DLLs, and you can see the different applications and the relationships between the applications and the different dependencies. Here we have a National Vulnerability Database that will provide information and mitigation for known vulnerabilities. These are pretty common vulnerability databases that are out there, so the different CVEs will show you what they are, how to mitigate them, what they're targeting. You just actually have to apply them. You also have things like this CISA top 10 or top 15 or hardening techniques. All of those are pretty common now. All you have to do is actually do the research and apply them. So this isn't 10, 15 years ago where there weren't standard organizational practices or standard best practices. Now there are lots of best practices for determining, like the SANS top 10, hardening. That way you know how to harden your server and what features and roles and figures should normally be hardened, how to test and verify. So, look at vulnerabilities, check, verify, test again. Understand these are not one and done, these are repeated cycles. Alright, so moving on. We have identification and authentication failures. This is basically identify, validates credentialing against the chosen file or database. Authentication uses submitted credential requests and other information to verify individuals' accounts and submitted credentials. The interesting part here is those that have been authenticated can be permitted to access the system or file or whatever items that they're trying to access they have permissions for or authorization for. But then we can start adding in additional layers like multi-factor authentication. This requires a verifying element over and above the standard just something username, password. Some mitigation techniques here are strong password rotations, password checking, and required changing, encryption of the passwords, encryption of the transmission of the passwords. Make sure things like session IDs are protected and caching and back button items are invalidated. A huge part here is test authentication and even try capturing the network traffic to see if the passwords are exposed. Again, testing, checking, verifying. A huge thing that a lot of companies don't do is bothering to check to make sure that their security measures actually do what they think they're doing. So when we're talking multi-factor, it's normally something you know, like a PIN, password, something you have, a card, a token, a phone, something you are, fingerprint, voice, facial recognition, voice recognition. Sometimes you can add a fourth, but normally these are the top three. The fourth one is a location. Are you operating at a certain location? That could mean a difference for multi-factor, and that's not as common. And then you can also have a current time. Maybe you're only authorized to access the resource Monday through Friday, 8 to 5. So there could be a time component here. Software and data integrity failures. Applications rely on plugins, libraries, or modules, oftentimes from untrusted sources, GitHub repositories, and other forms of CDNs. An insecure continuous integration, continuous deployment pipeline can introduce potential for unauthorized access, malware, compromises, and all that fun stuff. Big part here is pay attention to where you're getting your libraries and module and plugins. Make sure they're actually working. Also, test, verify, and run vulnerability checking against them to make sure that they're functional. Mitigation. Use digital signatures to ensure updates or patches are downloaded from only authorized sources or approved sources. Ensure libraries and digital repositories are also secure. Verify the downloaded system components and ensure they don't contain any vulnerabilities or no Trojans. Implement a review process for code and confirmation of changes, i.e. basic change management. Lastly, ensure unsigned or unencrypted data are not forwarded without clearing a integrity check or digital signature, i.e. if data is not encrypted, verify that that data should be unencrypted. If it contains anything, it needs to be protected. That's what it means by clearing an integrity check, basically making sure what information is being allowed to be shared. If it's being sent and it's not protected, the assumption is someone's going to read it. Security logging and monitoring failures. Basically, logging omits audible events, no warnings or error messages are produced. Again, you have to check, verify, and test some of this. Suspicious actions of application software and APIs are not monitored, i.e. not set up correctly. Logs are not consolidated to a centralized authority. There's no SIEM, there's no alert triggering, there's nothing to show an attack or escalation. That means things aren't implemented or verifying correctly. Security logging, failure mitigation, basically get a SIM. Ensure things are logged appropriately. Ensure login, access control, validation failures are all logged. Ensure data is correctly identified. Ensure high-value transactions are recorded in a log file. Ensure effective monitoring and notification procedures are defined and in place so that suspicious activities can be quickly identified and then addressed. Alright, lastly we have our server-side request forgeries, or SSRFs. This is basically when a web page or app sends a request to a remote object, like a web page or a database, without considering whether the request object or its URL are safe, thus allowing attackers could alter the requested software to send an altered request to a negligent URL. Basically here, if the requests are not protected, you can actually have malicious content returned, or you can have things modified in transit. Again, best way to mitigate this is defense in depth controls, not one layer, multiple layers. Distribute remote resource access over multiple networks. Implement a denial by default or zero trusts. Rules and network access policies. Log all permitted and denied firewall traffic. Validate all of the credentials, client-supplied input data. Do not assume input data is clean, so validate it. Disable HTTP redirections, and enforce URL consistencies using the same structure and syntax in all website URLs. That way, you are good to go. And again, here they are as an overview, as in the book. Broken access control. The threats are access control permitted or denied incoming traffic to pass using defined rules. Mitigation and ACL. So look at the different threats and think about the mitigation strategies. For cryptography failure, data in transit transmitted in unencrypted or clear texts. Encryption keys are reused. Encryption keys are in programming code and may be out of date. How do we fix that? Injection. Insert a malicious script into a web page. See what happens. How would you fix that? Insecure design. Omit or misapply security measures that provide the security that's needed. Designs flaws uncorrected during the development phase. Again, how do we fix that? Security misconfiguration. System administrators fails to understand the default configuration settings of the hardware and software and the configuration changes for the existing infrastructure. How do we fix that? Again, we're looking at the third column to talk about our mitigation strategies. I am not reading them. I want you guys to actually go through and think about them yourself and compare and contrast your response versus the response in the third column. Vulnerable and outdated components. Again, no inventory of all components installed in an OS. The software is out of date and unmanaged. What do you do? Identification and authentication failures. Identification validates that a person who requests access has correct credentials. Authentication, users submit their credentials to verify the identifying person and can be authenticated. What are some ways to handle our authentication process for something you know? We have our software and data integrity failures. An insecure pipeline can introduce potential for unauthorized access, malicious code. How do we fix that? Security logging and monitoring failures. Logging omits audible events. How do we fix it? Lastly, server-side request forgeries. Web app requests an object without validating the requested object. How do we fix it? Those are the types of questions we have to be asking. Additional web threats not in OWASP could be a drill down version, so do keep that in mind, but information leakage and improper error handling. Errors happen. So when things occur and an attacker exploits information in an unsecured error message, how are we getting things? When we're getting error messages, are they logged? Are they exposing information? Are they exposing components? What's going on? Information may include within an error message. If an attacker tries, and they do get error messages, they might get error tracing information, they might get details for names, verification of a specific file type, or they could get more database details. So error messages need to also be sanitized and make sure that attackers are not able to pull as much data from them. Unsecure communication, basically key exchange for VPNs or SSLs need to be kept in check so that things can be secured using appropriate secure communication channels like key exchanges and appropriate SSLs. Failure to restrict URL access, that's a big one. So when information on a web server is not sufficiently protected, users can find hidden URLs and expose sensitive data using dorking techniques. And the sad part is, these are pretty common and easy types of an attack. Mitigation is implement access controls for each of the functions. Test, verify, check. Attack strategies, authentication and authorization attacks, client-side attacks like XSS, or other forms of CSRF type attacks, command executions or directory transversal attacks. Best practices for mitigating attacks is tests. See if your web server is actually secure. Do a pen test on it. See what happens. Do not assume everything works correctly. Check, test, verify. Alright, that's it for this. We looked at types of traffic to websites, analytics, user input, looking at the OWASP Top 10, and strategies and best practices. Thank you. Alright, that concludes this video lecture for this chapter. If there's any questions, thoughts, concerns, or issues, please don't hesitate. Feel free to reach out. Thank you.